Okay, so with this one, we have Leona and Fred are friendly competitors in high school. Both are about to take the ACT college entrance exam. They agree that if one of them scores 5 or more points better than the other, the loser will buy the winner a pizza. Suppose that in fact, Fred and Leona have equal ability so that each score varies normally with the mean 24 and standard deviation of 2. The variation is due to luck in guessing and the accident of specific questions being familiar to the student. Weird. The two scores are independent. What is the probability that the scores differ by 5 or more points in either direction? So basically, we have, if we had our little diagram, and we had the mean down the middle, and then to either side, we had a difference of 5. We care about this region over here and over here. But this in the middle, we don't care about. So we only care about the stuff off to the far side because we care about the difference of 5 points. So basically, you do the normal CDF in both directions. You do the normal CDF in both directions for it. So you would have one that's, which it should be the same because it's, so you really only need to do it one time. And then we're going to add them together because obviously one's in the positive direction, one's in the negative direction since these are the same number. So you have the normal CDF of, you can do like 5 to, or wait, not 5, hold on. Wait a second. Yeah, okay, 5 to, you can just do something like this because that'll just be a really big number, but it doesn't really matter. I mean, you can't go higher than like a 36 on an ACT, so anyways. And then the mean is 24, standard deviation of 2. So you can get what that value is. There should be a scientific notation button. It should say like EE, I think. It'll be like second, and then it's somewhere near the trig functions. I want to say it's above one of the top numbers. At 1? Oh, wait a second. Hold on. We have 2 people, so we have to change these numbers a little bit. Okay. Well, no, so like the mean isn't gonna change based on what we've said, so the mean is gonna basically end up being 0. So the mean would be 24 minus 24 because it's gonna be the same, the difference in it is 0. And then the standard deviation is 2, but we can only do standard deviation with or like we have to change it to variance to add them together, and we always add standard deviation. So it'd be the square root of 2 squared plus 2 squared, which is the square root of 8, or approximately 2.83. So we would need to switch these numbers to that, and then do it. Let's go 3 decimal places.
So it's 0.039.
Okay, and then multiply that by 2 because we need it in both directions because that just accounts. So you said it was 0.039 or something. So that only accounts for this side, so multiply it by 2 to also get this side or add it to itself.
Okay, so it's 0.078.
So 0.078. So or about 7.8% of the time their scores will differ by 5 or more points. It's a long week, Kavanaugh. Literally something every day. But next week's a short week, so that's nice. Huh? You only have 4 days of school, though.
I need more than 4. I mean, no, I don't need more than 4 days. I need more than 1 day.
Yeah, after that, it's like a month before we get another day off. All right, last one. I'm not feeling number 11. All right. At a certain coffee shop, all the customers buy a cup of coffee. Some also buy a donut.
What happened to number 10?
That is number 10.
Oh, I thought I said 12 for a second.
Oh, no, we're skipping 11, though.
I don't have my contacts in it, so I can't see.
The shop owner believes that the number of cups he sells each day is normally distributed with a mean of 320 cups and a standard deviation of 20 cups. He also believes the number of donuts he sells each day is independent of the coffee sales and is normally distributed with a mean of 150 donuts and a standard deviation of 12. The shop is open every day but Sunday. Assuming day-to-day sales are independent, what is the probability he'll sell over 2,000 cups of coffee in a week? So, we're told that for coffee and then donuts, we have a mean of 320 cups, 150 donuts, standard deviation of 20 cups, and 12 donuts. And this is all per day.
Wait, the X is that standard deviation? Is that
The mean.
the mean?
The little sigma is standard deviation. So that's for each day, but we want to know about the entire week. So we need to change our mean over from a day to a week. So how would we change that? They're only open Monday through Saturday.
So what we're trying to do?
So I want to find the mean for the week. How many cups he expects to sell in a week?
So you divide 320 divided by 6. You said.
This is for one day. I want for a whole week.
I'll say 125. 320 plus.
And that's 1,920 cups.
Yeah, that's how much they eat. Right, so.
They sell. That's how many cups of coffee they sell. Because right now all I care about is coffee. So then the standard deviation for coffee It's 20 cups a day. So 20 squared, because we got to change it to variance. Then we've got to multiply that number by 6. Then we can take the square root of it.
So it's 400 times 6, 1200. 48.99.
So we'll make that 49 cups then. So if I were to look at this, I want to know that he sells, what are the odds that he sells over 2,000 cups in a week? So we're saying if he sells the average number every day, this is all he would sell. So to look at it, so our mean is 1,920 cups. But we want to know if he could sell 2,000. So I care about this area over here.
So the minimum, or the smallest number is going to be 1920.
Nope, the minimum is the amount that we're looking for.
So
This is the mean. So this is what's going in. Oh.
So when you plug it in,
So this is this value.
Okay.
Or X bar, however.
So it's gonna be 2,000, and then 1E99, 1920, and then 49.
Yep.
It's the first time I got it right. For like a whole week. Yeah. 0.513.
0.5 or 0.05?
05.
Okay. So that would be, we'll just call that 5.1%. Is the probability that he sells over. I'm not going to write out all of it. So basically there's a little more than a 5% chance that he sells over 2,000 cups in a week. So then, if he makes a profit of 50 cents on each cup of coffee and 40 cents on each donut, can he reasonably expect to have a day's profit of over $300?
So what you just like multiply 50 or 0.5 to 0.5 to 320.
0.5 times 320?
Yeah.
Mm-hmm. So we would have, so I'm going to basically remake this chart here, but for money. So coffee, donuts, X bar, sigma. So 0.5 times 320. So that is $160. So for each day, he would expect to make $160 on coffee. Then for donuts, what would we do?
0.4 times 150.
0.4 times 150, which is $60. And then for standard deviation, what would we do?
What did you say?
I said for standard deviation, what is the standard deviation for the money?
We gotta find the variance first, or no?
So since this one is strictly multiplication, we don't have to.
Okay, so it's 0.5 times 20.
So that's going to be $10. And then for donuts, 0.4 times 150, which is, nope, not 150, 12. So then that's $4.80 or $4.80. So then our expected value for the amount he expects to make in a day would be 160 plus 60 for the mean. So he would expect to make $220 each day if he sells the average. So then the standard deviation for this, we're going to have to now, because we're going to add them, we have to convert them to variances first. So it'll be the square root of 10 squared plus 480 squared and that's $11.09. So then we want to know the chance that he makes, with a mean of 220, what is the chance that he makes more than 300? So
So it would be 300, 1E99, 220, 11.09.
yep.
I don't know. I got 2.74 something. I'll plug it in. You said 300, 1E99, 220, 11.09. Yeah,
It's 2 something?
I got, yeah.
It should be 0 something. Oh, it is, because it's times e to the negative 13.
But what does that mean?
That's scientific notation.
Oh.
So this means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then there's the 13 before the decimal point. That's why I was like, wait a second. So this basically means there's a 0% chance, basically, that he makes that much, so it's very unlikely.
It's 13 zeros.
It's 12 zeros and then a 2.
Okay.
You've seen scientific notation before, right? Okay. I was like, we might need to back it up if not.
I never formally learned it. Like, it was
Oh,
just
you'd
like-
learn it with Miss Marshall if you had her.
I learned it. I learned. I learned it last year, I think. But like, I've known it since like 6th grade.
Yeah, it's like you use it a little bit every year, but like not enough to really think about it. All right, so then the last part, what's the probability that on any given day he'll sell a donut to more than half of his coffee customers? So the mean would be 150, because that's how many donuts he normally sells, minus half of 320, which is negative 10. Then standard deviation, we have the standard deviation for donuts needing squared. So 12 squared minus, or wait. I think it's supposed to be plus. It's supposed to be plus. Plus half of the standard deviation for donuts, which is 12. No. Wait. Half of 20, not donuts. Half of the coffee customers. And then that number is getting squared. And that comes out to be $15.62. So then we care about more than half, so we're looking at the right side of the graph. So the mean is -10. So we basically say that he wants it to be 0 or more, because that would be more than half. So we care about this area over here. So normal CDF of what?
0, 1, 99, -10, 15.62.
Yep.
You just have practice it.
I can just see it now, Coach being like, why did you give him a whistle?
He'll probably let me. I'm not gonna use my power. Maybe. Got 0.261.
So 26.1% chance that he sells a donut to more than half the coffee customers, basically. All right. I'm not going to do 11 because, we've done enough of them. So let me see. I'll go ahead and give you the problems and then